Bienvenue. Donc, ce soir, on va parler de JVM, d'optimisation, de Classloaders avec Simon Barpen. Donc, je lui laisse la parole.
Bonjour.
Bonjour.
Je m'appelle Simon Maple.
Wow.
There's more. J'habite à Angleterre. Je parlais un petit peu de français. Donc, the rest of this session is going to be in English because you all can understand English better than I can speak French. I'm absolutely positive. So this is a session called Do You Really Get Class Loaders? The answer to that question is no, because I don't believe anyone really gets class loaders. But this is going to be hopefully a good stab at unlocking some of the questions we may have around class loaders. So this is me, Simon Maple. I'm a technical evangelist at Zero Turnaround. The JRebel guys, those people. No one ever knows Zero Turnaround, but lots of people know JRebel. We're the JRebel guys. Prior to working for Zero Turnaround, which I've done for about 1 year now, I used to work for IBM on WebSphere Application Server as a developer. So I developed from around version 4 up to around version 8.5. Any WebSphere users? I'm sorry about that. There's quite a lot of my code in there. I apologise for that. So who's on Twitter? Loads of people on Twitter. Follow me at SJ Maple. I love followers at SJ Maple, and please tweet about this session as we go because I love reading them after the session. I get paid by followers, so please. So this is what we're going to be talking about today then. We're going to look at the basics of class loading. Look at how you can do it implicitly and look at how you can do it explicitly. We're going to look at problems and solutions. Some problems which are obviously class loading problems. Problems that we have all experienced in our general day-to-day Java development. And then we're going to look at some problems that you wouldn't even think about being a class loader problem. But when you actually look under the covers, it actually is a class loader problem, and you know you can be questioning for ages. What is the problem with my code? Why isn't this working? And you actually look under the covers, and it's a class loader problem. Now, something that's very, very important: leaking class loaders, and why class loaders leak, and how we can fix it, and why class loaders leaking is more important or more destructive than leaking classes. If I'm speaking too fast at any point, just throw something at me or just shout at me and I will slow down. Also, if you have any questions, put your hand up, shout, throw something again, and we'll take questions as we go. Finally, I will do a very, very brief demo about JRebel, if that's okay. One of the reasons why we do this presentation from Zero Turnaround, this is an adopted presentation. This has been done before my time at Zero Turnaround. One of the reasons we do this presentation is because the software which Zero Turnaround write, JRebel, integrates very, very deeply with class loaders. And so as a result, a whole bunch of this material has formed because of what we have learned about class loaders. So who's used the class loader API before? A few people. Why? Why would you do that?
I had a degree to pass.
Oh, you had a degree to pass. Yeah, if it's academic, then that's fine. So actually going to a class loader API and playing with it is something which you should do if you really know what you're doing and you're doing it for a reason. If you don't have a reason to do it, don't do it. Leave it alone. Classes can be loaded by themselves. This is the class. That said, I'm going to show you it and talk you through it. This is the class loader API. It's very simple and it's just a Java object, so nothing to be frightened of yet. There's only 5 methods. The first one and most used method is load class. This is very, very simple. You pass in a string name, which is a combination of your package name and your class name. So a.b.c.this. My class. And we would get returned a class. And from that class we can instantiate an object and make use of that object. So this is by far the most well used. Next is define class, which takes a byte array. This is typically when the class artifact isn't local. So this could be, you might create the class from the network or something like that, and you get a byte array in, you use define class, and you create a class back. And from that, you can then, similarly with load class, you construct your object, instantiate your object, and play with it from there. So those two are all about creating your classes, actually getting a class object back. We can do a lot more. We have two here, get resource and get resources. Really, really useful methods, particularly when you debug. And debugging is really important when you get down and dirty with class loaders, because whenever you have a problem with class loaders or some class loading issue, it's all about verifying your assumptions, because very often your assumptions, what you think is happening, is very, very different to what is actually happening in the runtime. So it's very, very important to make use of these. What we simply do is we pass in a string, which is the package name and class name, and we get a resource back. We get a URL back as to where the class loader is getting this class from. Or in the case of get resources, we get an enumeration of URLs. One method here, get parent, is very crucial. It defines the structure of how class loaders are linked together. Class loaders aren't flat. There isn't just one class loader. If we take WebSphere as an example, I may use WebSphere as an example because I probably know it best. If we take WebSphere as an example, WebSphere has around 250 class loaders in its product. If you take something smaller, JBoss, I think, has 150 class loaders. So we're not talking about just 3 or 4 class loaders. We're talking about a huge hierarchy of class loaders that are linked together. And get parent specifies the hierarchy. So one class loader will have a parent, that class loader will have a parent, and this link between the class loaders is crucial, because when we call either load class or define class, the behavior in those methods may say, I'm going to go to my parent and ask my parent first, can you load this class? And that class loader will say, I'm going to go to my parent, and it continues up till it finds a class loader that is at the top that can load the class. If it gets to the top and it can't find that, it then goes back to see if each child class loader can load the class. There are exceptions to that which we're going to look at, but that's typically how the class loader hierarchy is traversed. So we're going to start with a very, very simple example. Here we have a class A. It has a method, do something, and we have a constructor for class B, and we call a method on it. At this point here, where we are instantiating class B, we're going to load B, because this is the first time which we are accessing class B. So who can tell me which class loader we're going to use to load class B? Sorry?
Same class loader as A.
Exactly. So the answer was the same class loader as A. So what would typically happen is that the class loader for class B will very much depend on where you are using class B. In this case, we're in the scope of class A. We're in a method of class A. As a result, we look to that scope, which is class A, and what we'll effectively call is we'll grab the class loader of class A, and we will try to load class of class B. So it typically goes to its local scope first. Whether or not it's the class loader of class A, which actually eventually loads the class, or one of its parents that loads the class, doesn't matter right now. The key part here is we're in the scope of class A, so we use class A's class loader. Right, now we go to the wonderful world of Java EE. And what we've talked about previously really applies to Java SE. So if you have a class loader, the typical behavior is to when a class loader gets a request to load class, it will go to its parent, and it will always go to its parent before trying to load using its own class path. So it'll go as high as it possibly can. So in this example, if this was kind of pure J2SE, if this was a class loader structure, we would go right to the top, the parentmost class loader, to try and load that class. And this is great because if we stuck to that every single one of these class loaders would always go up to the top. And if this class loader could load our class because it's on the class path, it would only ever have one loaded class, because this class would be reused by everyone. So that's the benefit of having the highest class loader, the parent-most class loader, loading the class for us. However, in Java EE, we have a number of application servers, and this differs from app server to app server, but we have a number of application servers that in their web app class loader, they will look to their local class loader, class path first, before going to their parent. So in this case, let's take Tomcat as an example. The out-of-the-box Tomcat behavior is if we're in the scope of wall 1 and we try to load a class, we will always look to this class loader first, the class path in this class loader, before delegating up to our parent. If the class we're looking for is not on the class path of this web app, so this web app's class loader, only then will we delegate back up. And this really only applies to web app class loaders. As soon as we get into the app ears class loader, we're very, very typical again. We will go to our parent first, which means we go to our container or our shared class loader. Then we'll look to see if we can load the class, and if we can't, because the class isn't on our class path, we'll then come back to our app1.ear and look for it here. So our order, if we're using something like Tomcat, would be try and load it in the wall 1 class loader first, then delegate up to the container, up to our shared class path, and then try and load it there, and then come back to our app class loader and load it there. So this difference in class loader behavior is one of the things which gives us things like jar hell, but also great exceptions that we never thought were possible. Any questions on that so far? No? Awesome. Okay. Right, so now we're going to jump into some code. We're going to look at some problems from fairly basic up to a little bit more interesting. And we're going to see what tools we have at our disposal to debug, to confirm our assumptions. And then we're going to look at more interesting and in-depth exceptions. So, we're in Eclipse, good old Eclipse. Here I have a Tomcat server, which is managed by my Eclipse environment, and I'm running a web app. This is my web app here, and I have 5 servlets. I'm going to open one of my servlets up so you can see some code, very, very basic code. So all we're doing, can everyone read that okay? Can anyone not read that? Good. So what we're going to do, we have out.print, and we're creating a new class, util1.sayHello. Really, really straightforward. Can we see util1? Yes, we can. And we have a method, sayHello, which just returns hello. Really, really simple. So when I run this, I should just get hello as output. Let me try that. And we don't. Boom. We get a no class def found error, util1. Has anyone in this room not seen an error like this? Has anyone not seen this error today? So stupid question then. What does this error mean? No prizes for this. What? Sorry? We didn't find the class, but we can see it. We can see the class here. So why are we getting this exception?
It's not in the same project.
It's not?
In the same project.
Doesn't matter. It's not in the same project, but we're linking to it. It's not in the class part, so this is a runtime, right? So just because everything compiles and works in our IDE doesn't mean our IDE is the same as our runtime. Okay, so this is pretty basic stuff. Very, very often that we assume our runtime is always identical to our IDE, and we always blame the runtime because we think we've exported everything and it should just work. So how can we verify that what we're seeing is actually what we expect? What I'm going to do is I'm going to comment something out, uncomment this, and what this new code is doing. So we are, actually let me go back, util1 is being loaded, or it's trying to be loaded. We're going to try and load it from test1, because that is the class loader that we are in the scope of. So, what we do, our code to debug this, is to say, I'm going to grab test1, I'm going to grab the class loader from test1, I'm going to cast that to a URL class loader. This is a very, very common class loader which is found in many different containers. But it's got a really, really good method, get URLs. And what this is essentially saying is, give me all the URLs that you've effectively got on your class path, and then I can see the world from your kind of point of view. And this is where we're verifying what our class loader is seeing. So I'm going to save this, and by the power of JRub, we get this. This is our class path for test1's class loader. And we can see that we've got two things on it. We have the CL webinf classes, and we also have the CL demo jar.jar. And I know, just because this is an app I'm familiar with, that this is where our code should be. So let's take a look at this location. Let's see why this code does not exist. So if I cd, no. So if I go there, I can jar minus tvf CL demo, and we can see, yes, we're verifying it. We're following the steps of the class loader, and we're understanding what the class loader is looking at. We can see this class doesn't exist. It's probably a stale jar because we haven't packaged our app correctly, and we haven't pushed it out. So this is a very simple example, but one that in a complex system can very easily happen, because you typically have many dependencies, and when you bundle an app together, it's often not a trivial thing to do. Okay, so let's move on to something more interesting. Test 2. I say more interesting, it's quite similar. Test 2. Our code says, let's see, out.print. New util2.sayHello. Pretty similar, but we've got a util2. Click on util2. That code looks very similar as well. So fairly straightforward. Let's see what exception, or let's see if we get hello. No, we don't. We get an exception. No such method error. I'm sure everyone has seen this as well, right? Another question with no prizes. What does this mean? No such error. Yes.
The class loader found the class, but the method is absent.
But the method is absent. Very, very good. So the class loader has found the class. That's the first thing. Okay. We know that util2 is on the class path, but the method is absent. So the question is, why is the method absent? Very, very often, it's because there's two possible reasons. Really, most common reasons. First of all, you haven't packaged everything together, you haven't built the latest version, so you're actually running on a stale runtime. The second, and quite common reason as well, is that there are actually two versions on your class path. And Java, with the lovely flat class path we've got, has picked the very first version on your class path, and it might be the older one of the two. One of the things I typically do in my development when I'm testing patches is I'll very often, and I'm sure lots of people in this room have done this as well, I name my jar with an underscore at the front, so I always know it's very, very high on the class path. Anyone else do that? Just me, what a cowboy I am. Okay, so on test 2, what we're going to do now, we're going to verify our steps. Very, very important. So we're going to do it again. We now know this class exists, obviously. So, test2.class.getClassLoader. We're grabbing the class loader of the scope we're in, which is test 2. We call getResource this time because we know it exists on the class path, and what we're saying is, where are you finding this class from? The resource we're interested in is util2. So we get the name of util2, the full qualified name of util2. We replace the dots for slashes in our package name. And we add a .class in the end. So what this is effectively doing is giving me a full path of where this class actually exists on my file system. So I'll save that and rerun. And this is what we get. it's a jar file. Interestingly, it's exactly the same jar. And we can see inside that jar, there's a util2.class. So it is the same jar that we've got, that we literally just saw here. So it's this util2. So now, oh, look at that. It is this util2. So we can now verify, is this actually the one we think it is? If it is, then we need to understand, then we just need to package it, repackage it. One thing I want to show you though, is let's go into that and grab the util2. Util2. And let's Java app it. So Java app is a very useful command. Java app's a very useful command. What Java app has, many people use Java app here? So, okay, quite a few. So what Java app does is it allows us to grab a class file and actually have a look at the bytecode that comes with it. So what can we see here? Where is it? Here. These 3 lines here. We can see public class util2. We can see a default constructor, and that's it. So yes, this really is. And if there was any code in here, you'd actually see the bytecode as well. It's actually quite fun to look at. Interestingly, if we actually go to util2, util2, we don't, oh, alright, okay, this is not the version that we're looking at, but we don't actually have the default constructor there. So, during the compilation, that's where the extra bytecode for the default constructor is created, just out of interest. So, okay. There we go. Okay, so that's Java. That's we can verify that now, and we can just repackage that up and push our new version out. So let's have a look at possibly one of my favourite most exceptions in the world. Test 3. And I'm sure many people have seen an exception like this before. So our code. We're all Java developers, so we love factories, right? We're going to use a factory, and we're going to call instance untyped on this factory. If we go and have a look at what instance untyped does, really simple, it returns us back an object. And what we do is we create a util3 class, create a util3 object, and return that as an object. Nice and simple. When we come back, we cast it to a util3 from an object, and we call say hello on that class. So let's have a look at what wonderful exception we get. LinkageError. I wasn't expecting that exception. Damn. Okay. That's interesting. Let me just restart this. I might have something weird on it. Hey, there we go. It was a tomcat weirdness. This is my favourite exception of all time. We have a class cast exception. Util3 cannot be cast to util3. Great, no? What? Who's seen an exception like this before? Quite a few people. Who looked at that for the first time and thought, what the? So, for everyone else who hasn't seen this exception, why do you think we're getting this crazy exception? Any thoughts? Not the same. Not the same object. It's not the same class loader. That's the point. I'm going to show you a slide which better describes this than I can. Yeah. Okay, so this is what's happening. We have a web class loader at the bottom, and its parent class loader, which in this case will simplify to... Hot corners are great. Let's put it in this corner. So we have a web class loader, and its parent is a shared class loader. The first thing we do is this line at the bottom. util3 u equals factory3 dot instance untyped, and then we cast that to util3. So the first thing we want to do is load the class factory3, because this is the first time we're using this. We go to load factory3. So we're a web class loader, so we look locally first. We look to our own class path before delegating up. Can we see factory3 on our class path? Nope, we can see util3 and we can see test3. So we can't load that locally in our webinflib or anything else on our local class path. So we delegate up to our shared class loader. Our shared class loader does have factory3, so it loads it. Everything's good. In our factory3 class, we call factory3.instanceUntyped, and the code that runs is new util3. So we're constructing util3. It's the first time we've seen it, so we're going to load this class. The trick here is we load this class in the scope of factory3, because that's where we are. And so we're using the same class loader that loaded factory3. So we try to load util3 in the shared class loader. Can we see util3 in the shared class loader? Yes, we can. So the shared class loader loads both factory3 and util3. We return this as an object. So back here in test3, factory3.instanceUntyped returns an object which we cast to util3. And this is the first time we see util3 down here. So we're going to try and load util3 using the same scope as test3. So we're up here in our web class loader, and we're going to load util3. It would be lovely if we could call our parent and use the same util3 as the shared class loader. But that's not the behavior of a web app. The web app class loader goes locally first. So the web app class loader is going to look locally for a util3, which we also have here. This util3 could be exactly the same as this util3. It could be exactly the same bytecode, literally the class copied, okay? But its identity is going to be different at runtime. And the reason its identity is going to be different is because an identity of a class is three things, three parts. The class name, the package name, and the class loader that loads it. That's the identity of a class. So it could have the same name, the same package, the same bytecode, the same timestamp of when it was compiled. But because it's a different class loader, you will never be able to cast the two. So as a result, we get a class cast exception. And the limited information we have in that class cast exception is literally just package and class. And as a result, it's util3 cannot cast to util3. Awesome exception. So, what are we going to do now? We're going to try and verify what we see. We've got an exception. We don't have this slide to explain it to us in our development environment. So we're going to need to try and debug and try and find some information that will help us come to this solution. So we go to test 3. I'm going to comment this line out. What I'm going to do is, I know it's util3 being the problem. And I know where util3 is being used. It's being used in two places, in my test3 and in my factory3. So what I'm going to do is I'm going to grab both test3 and factory3. I'm going to get the class loader for both. I'm going to get the resource. This might be the same class loader. You don't know. We don't know at this stage. We're going to call getResource, and we're going to pass in the util3 package name and class name on both. We're going to replace dots for slashes and add a dot class. So we're effectively saying, where on the file system is this class loader, test3's class loader, getting util3 from? And exactly the same question to factory3. So we've saved that, and we run it again. And we get two different values. The first value is the webinflib cl demo jar.jar util3.class. So this is the same jar that we were looking in before for util1 and util2. The second one is a jar file again. This is in the Apache Tomcat lib shared jar. So this is effectively the lib directory which is shared across all web apps. And we can see it's in a shared jar, and that's util3.class. So we can see they're getting it from two different places. So what do we do here? This is where we have to make a decision. Do we say, I don't actually want it in that shared class, in that shared lib directory, because only util, this servlet or this web app is using it, therefore I'll remove it from that. Or do you say, there's no point in having util3.class locally here, because there are many web apps that are going to use this. So you could push everything into your shared directory. Or you could say, I'm not going to use a factory, but that's not very Java. Okay, there are different variations of this as well. I'm going to show you a couple. Test 4. So what test 4 is doing here is we're calling factory3.instance.sayhello. And you'll notice that what we're missing is the util3 cast. If we go to factory again, we can see instances here. And the reason we're missing that cast is because rather than return an object, this time we're actually returning util3. So we don't have the cast in our test 3 or test 4 package. In our test 4 class, sorry. We don't have this cast. So let's run this and see what we get. We get another exception, and this time the exception is a linkage error. That always happens to me in a linkage error. Yeah.
Or maybe you can use the other one. Okay.
That's good. See how dangerous linkage errors are. Just saying the word does that. So a linkage error, it's not quite a class cast exception, but we're not casting, so we wouldn't expect a class cast exception. This is more of a kind of internal exception that we're getting for the same thing. So this is another manifestation of exactly the same problem that we're seeing here. There's no different. The only difference is how we're getting this exception, and therefore we get a different exception. Another variation of this is test 5. This is another fun one. This is one that if you ever get this exception, which I'm sure many of you have, you would never believe it to be a class cast exception. You would never believe it to be a class loader exception. And you'll do the same thing again and again and again, and I'll tell you what that is. So what we're doing, this time we're calling instance package on the factory. And instance package is exactly the same, apart from the fact that we're missing our access modifier on the method. We haven't got this public access modifier. As a result, this method is limited to any class in the same package that we're in. Okay? So, let's have a look at the package. We're in the default package here. Test 5, we're in the default package there. Everything should be fine. If we run this, we get an exception, we get an illegal access error. So what would I do if I saw an illegal access error? What would I do? I'd think, my runtime's clearly not the same as my IDE. I'll repackage it and I'll send it out again. I'll restart everything. I've got the same exception. I'll repackage it. I'll send it out. I'll restart it. I've got the same thing. I'll probably do that maybe 4 or 5 times before I start thinking, yeah, this runtime is up to date. What's happening? And what is actually happening? Anyone got any ideas about what's happening here? Has anyone seen this before?
Yes.
Yeah, a couple. How did you fix it? You didn't find a solution. So you just so you unassigned the defect to someone else.
I tried the GBoss 7.
Yeah.
They have a ClassLoader, which name is module ClassLoader.
Uh-huh.
Based on it's very different than this one.
So your fix was to change the container your application was running in. Excellent. And it worked. What's happening here is, I mentioned a package has, I mentioned a class has 3 things which uniquely identifies it. The class name, the package name, and the class loader that loads it. A package is very similar. It has 2 things that define it. The package name, just the string package name, a.b.c. whatever. But the other thing is the class loader that loads it. And what we're getting here, well not the class loader that loads it, the class loader that's using it. What we've got here is 2 classes. in separate packages. And as a result, these packages, you know, the identity of these packages are going to be different because it's class loader and package name. So what we're effectively seeing here, is it the same package? Well, it's not the same package. Just because the package name is the same, they're different class loaders. I might as well have a package with 100 things in it and a package with nothing in it. That's how different they are. So we're getting an illegal access error because we have different class loaders. Okay? Okay, so let's quickly summarize what we've been talking about. So we started off nice and simple with an OClassDefFound error, or you can get a ClassNotFound exception as well. So what do? Well, the nicest thing you can do is get URLs. Let me know what you see as a class loader. Let me know what you can see, what's visible to you. That's what we're saying to the class loader. Container logs can be quite useful here, but not very often. You can also do a find for all my jars and then grep the class just to see where it is, why it's not on the class path, that kind of thing. Wrong class found. One of two different options here. Either we have a class with this name on the class path in our runtime, but it's a different version to the one in our IDE, or we have multiple versions of this class across our runtime, and our runtime is picking up a class, but not the class we want. Okay, so this is what we've got. A couple of really useful things here. Minus verbose :class. This is really useful on the JVM. It tells you what the JVM is doing, what it's loading. That can be very, very useful, particularly if it's some third-party container third-party framework that doesn't give you the name of the class it's even trying to load. That can be useful there. ClassLoader.getResource. This is very, very useful. Tell me the exact place where you are finding this class and give me that location on the file system so I know exactly where to look for the problem. And Java, if you really wanted to look into the bytecode, you can do that all day. If you wanted to change it, you can do it in a hex editor, but I wouldn't trust it. We've done that. So, more than one class found. Essentially, more than one class loaded, really. So, you know, we're loading in different class loaders. We get a number of different things. You can have a linkage error, class exception, illegal access error. This is a tricky one, because you don't blame the class loader first. You blame the runtime, you blame yourself, you blame your life, you blame your decisions, and then you blame the class loader, right? What's useful? ClassLoader.getResource is the most useful here. Minus for both class as well, because you can see some class loader information. Any questions on that before we look at how some classes are reloaded at runtime and how some of the problems we can get into with things like you know, when you refresh an application in your runtime? Any questions on class loading? You're making my job easy. Here we go.
Very fair. Is that the reason we need frameworks like Spring, because some of the classes cannot be loaded at the same time and we actually need to extract the interface?
So the question was, is that the reason we need Spring? I don't know, I haven't heard of a reasonable reason why we need Spring yet, to be honest. I don't think this is, no, I wouldn't say that necessarily. I think some people might hate this, some people might love it, depending on how you see OSGi. It could be considered a reason why you might want something like OSGi, or something like JBoss modules, because what you're effectively doing is you're doing away with the Java class path, the flat class path, and you're saying, I'm going to tell you where I want you to look for my classes. You can still have class path problems in OSGi, and they can be even hairier and horrible, but you have that ability to link to particular versions and particular modules. This is really a problem because of what we've seen here is a problem because of the delegation in some class loaders will go to their parent, some class loaders will do local first. If we take an app server, I'm going to use WebSphere as an example. If we take an app server like WebSphere, what WebSphere will do is it will, even for the web app class loader, it will prefer parent. So you won't get into any of these problems with WebSphere. You can get into some worse problems with WebSphere, but you won't get into some of these problems with WebSphere. But what problems do we see then? here. What problems do we see then? Well, there are a whole bunch of frameworks and libraries that WebSphere use up here. Do we want to use those if we're using the same classes ourselves, or do we want to use the versions we want to use? If in the instance, let's say Log4j, this is one of the things that many people using WebSphere want to change. We want to use a newer version of Log4j down here. But every time I try and get a Log4j class, I end up using the WebSphere version. Because every time we go to the parent first, we use the version which is available by the runtime. So how do we get around that? Well, you can switch this to say use my local versions, and yeah, that's what Spring does. That's a side effect of Spring, the fact that it's a library that you put into your war and everything is local. But you know, who's to say that's fixing it because everything's just local to your war, and so it's all using the same class path. Okay, that's not necessarily a Spring decision. It's a side effect of Spring because that's typically how you would use it. You could do exactly the same. I mean, with the previous examples where we're doing this, if we just pushed everything into your web app, you wouldn't have some of these problems either. But do you want a web app that's 150 meg and most of it copied across loads of different web apps? No, we don't want that. It's a management nightmare to do something like that. So you know, asking what the fix is pretty hard. Isolation's a good fix. I think there's an isolation JSR which hasn't been touched for 8 years, is it, or something like that? Maybe. What else is a fix? It's hard to say. Really, it's kind of an architectural thing. When you get the problems, how do you solve it? Where do you position your libraries? Where do you position your classes? Yes.
Yeah. So I didn't understand what you said about Spring. Yeah. So what does it change if you use Spring?
So typically when you use Spring, the entire framework is based in your application, in your war. So you're effectively using the same class loader for everything within Spring. So it's not necessarily a fix to anything. It's just the fact that you typically avoid a lot of those problems because everything is based in your war file. Is that the point you were making? Yeah. So Spring isn't by design a fix for any of this. It's just by the nature of where you would put Spring jars, you wouldn't get these with Spring, but you wouldn't get them with anything. They're where you put your libraries. It's not Spring specific. You wouldn't get these problems with anything where you have all of your libraries in your web app. Okay. Any other questions?
Yeah, another one.
Mm-hmm.
So I didn't really understand what you said. And also, you said that the WebSphere doesn't follow the inversion of delegation.
Uh-huh.
So WebSphere doesn't implement correctly the spec, or it's not specified?
It's quite fluffy, the spec.
It's not specified.
It's quite fluffy, yeah.
When you go to the ER file, you know, the ER packaging, it doesn't specify anything. So JBoss will do it one way, WebSphere will do it another way. And what you're mentioning about Spring, that's very, very common. A Spring web app usually runs on Tomcat. So everything is bundled in a war, and then you push it to WebSphere, and it crashes. You have to turn the class loader parent upside down. But the same thing would happen. You know, think of a Spring application running on Tomcat, and put the servlet.jar inside your war and put it in Tomcat. The same thing would happen.
Yeah.
Same problem.
So it's absolutely right. It's not specified. It's a little bit fluffy, and as a result, everyone does it differently. Tomcat does it differently to WebSphere. If you wanted to use a different log4j, for example, in WebSphere, and you wanted to bundle it in your war file, there is a switch. I think it's a switch on the container. And you basically say, it's parent first. You switch the web container to say, I want you to use, sorry, not parent first, parent last, yeah. You switch it to say parent last. And as a result, you would then get that default Tomcat behavior where you look locally first. Okay? So, vendors realize that there is no best way of doing it because there are advantages and disadvantages, whichever way you choose. If you choose the route where you don't get all these exceptions, then you can't use all the versions of the libraries which you want to use because the flat class path, that's how the flat class path works. If you choose to do it the other way, where you can bundle and override which libraries you want to use by bundling things into all one, then you open yourself to these problems. These problems are fixable. They're just hard. They're just harder to fix and harder to manage, particularly when your deployment gets large. If you don't do that, and if you do always go parent first, then that problem is much harder to fix, because then you can't use the versions of the libraries you want to use. Okay. So let's talk about class loaders, reloading an object. How do we reload an object? A class loader, the class loader is a very, very well-named API, because that's what it does. It loads. There is no reload and there is no unload. So once a class loader has loaded a class, that's it. You cannot do anything about it. If you want to unload that class, you throw the class loader away. So as a result, let's say we're in Tomcat and we've deployed our application. But now we want to change our application. We want Eclipse to publish our changes in our application. What's it going to do? Well, it's going to create a new class loader for our application. It's going to load all our classes again. It's going to pull some state across as well from our old classes to our new classes, or old objects to our new objects. And everything's going to be amazing, and everything's going to be great. Until we have some links across, and this hierarchy doesn't go away, and then we get a permgen exception, and then we have to restart Tomcat, and so on. So there can be massive problems with doing this, although it is faster. So we're looking at leaking class loaders. What does it mean to leak a class loader? We have a relationship between class loaders and objects. This should actually have an arrowhead here. From every class, as you've seen, we can access our class loader. So we can say get class loader. Every class loader has access to our objects, so that's absolutely fine. If we leak a class, that's all we leak. We leak one class. If it's a big class, we're unlucky. If it's a small class, we're lucky. If we leak a class loader, then we leak every single class that this links to. And if that's a huge number of classes, that's a big web app, then we're going to have a web app sitting around every single time we try and destroy this, but can't, because there's still a link. So I'm going to show you an example of a leaking class loader now. So we don't have enough app servers in the world, so we've created our own CT server. I'm not sure it will take off. So we have an example here. This is our app server. Very, very simple. We have a while loop, and as we spin through this while loop, every single second we spin through this while loop, we go to our web app factory, because we're great Java developers and factories are awesome. We create a new instance of our web app, store it here, and then we print out a message, which is the message of our web app, and also our counter. This is our counter, which we increment every single time we go through this loop. So let's take a look at our web app. Here it is. Here's our web app. The message we're putting out is version 1. The counter is going to be initialized at 0. And ++ will just do a simple increment. So very, very straightforward, very, very simple. The more interesting part is our web app factory. In our web app factory, the actual code which does the lookup is here. Every single time in this loop where we create this new web app, what we're effectively doing is creating a new URL class loader, and we're going to load this web app every single time with a new class loader. We're going to return that, and everything's going to be great. So let's run this and see what happens. App server. Run. There we go. So every single second we get that message out. Message is version 1. Counter is 0. Every single time it's 0. Every single one of these messages is being what we're actually doing. We're creating a new class loader. We're creating a new class of web app and creating a new object, passing that back. Our new object is initialized at 0 for our counter. Even though we're calling ++, we're throwing the whole thing away and we're creating it all from scratch. So I could do something interesting here. I could go to my web app. I could change this to version 2. And it changes automatically. Why is that? Because we've compiled our code. Our code is now there, and our web app, sorry, our class loader is grabbing that new code. It's loading the class again from scratch. It needs to do that reload. So we're picking up the new version. We create the object with the new version, and we see our new code running on the screen. Let's call it Paris Jug Rocks. There we go. But what we want to do now is, now we're creating this, we want to do something a little bit more intelligent. If we go back, interesting. Must have minimised it. There. Right, not you. Apply expenses. That's open office. Even Classloaders. Here we go. What we want to do when we create this new structure, and just before we throw this away, what we want to do is we want to recreate the object and pass that state across. So just before we throw everything away, we want to grab the version of grab the state of counter and pass it across. So very easily done, particularly when the code is there and I just need to uncomment it. Here we go. So in web app, I'm going to uncomment copy. I'm going to set copy on the iWeb app interface. And let's take a look at what copy does. So what copy does is it takes in a web app. So this is going to be called on our new object. So the object which we've just created with our new class loader. We're going to take this. We're going to take the old version on the left. Before we throw it away, we're going to say grab the counter of our old version and set our new version to it. So our counter's been incremented to 1. We want to grab that version and we want to initialize ourselves with the new version. The other thing we need to do is just before when we create it, we call copy, passing in the new web app, and we're done. So I'm going to stop this, run it again. And this time we get that counter that's passed across. So now every single one of these is still being created. With every second we throw away the full hierarchy of our class loader, class, and so on. But just before we do that, we pass the state across. I can still make changes if I wanted to in web app, just to show you that. Lots more. There we go. We can still make our changes, and we can still see them. And this is great because we can now code live and see our changes instantly. But this is a very, very simple example. Typically, in the bigger environments, you can't. It's very, very hard to do this because you do get leaks across when you recreate the objects and when you create the new class loaders with the old ones. So, I'm going to show you a leak. In our web app factory, what we're going to do first, this is our class loader code where we create our new URL class loader. This is an anonymous inner class. And what we're going to do is we're going to uncomment this line. And this is an array of longs, a large array of longs. And this is going to signify a whole bunch of classes which has been created by this class loader. Okay? So imagine this class loader has just a regular amount of classes. That's what this is signifying. So I'll save that. I'm also going to add a leak method, and this leak method is going to be called when we copy. So when we're copying state across, we're also now creating a link between our old object and our new object. And here's a implementation which holds that leak field. So let's run this again. Okay, so there we have it. We can still make our changes if we want. I can delete that, save it. Our changes are still being made. But I know in not very long at all, this is going to explode. There we go. How about that? That shows I've done this session too many times now. But we're awesome. Put your hands up if you're an awesome Java developer. One person in the room. Everyone put their hands up. Everyone put their hands up. We're not continuing. We're all awesome Java developers. As a result, on our JVM, we have a JVM argument, which means when our JVM dies because of an out-of-memory error, we don't just want it to die, and then we have to scratch our head trying to work out where the problem occurred. We want as much debug information as we can get about this JVM out-of-memory error, so that it doesn't happen again. So we're all awesome Java developers, and that means that when I look at my run configuration here, I have an argument. This is an argument which should be default on any JVM. Why would you not want this? Heap dump on out-of-memory error. Okay, this should be on all production environments, I think. When your JVM dies because of an out-of-memory error, capture everything you can get about the objects which were in memory at the time, capture all that, and give me that information as a file. Basically, if I look at my exception, we've got this line here, dumping heap to java_PID blah blah blah. This is outputting everything to a file which we can look at. So let's take a look at that file. Down here in G2 server. Going to, where's refresh? There. Refresh that. Okay. And here it is. Here's our file. I'm going to open this. I think this is called Eclipse Memory Manager or something like that. It's a good little tool for looking at these dumps. I'm going to click on the Dominator tree, and this gives us all the objects and all the cool links about everything in the JVM. We can see straight away there's 120 meg there. We're going to dig deeper into that to see what the problem is. So we dig deeper, we follow that 120, and look, it's going down now. And we'll notice that every single time it's going down by just over 8 meg. So let's dig into one of those. Interesting, it's a leak. Example.webappfactory $1. This is our class loader. This is the class loader leak. This is the $1, which is the anonymous inner type for every time we create our class loader. And inside, we can see that long array. This is a representation of every single class that this class loader would have loaded. As a result, our class loader leaking is very, very important, because our class loader leaking will leak every single class it has ever loaded. So that's why it's more important than a class leaking. And at this point, Tomcat would blow up with a permgen error, and we'd have to restart it. And you know, that's the kind of thing which many people, I'm sure, have seen, and that's the reason behind it. Okay. So that's why we have leaking class loaders. Okay. Any questions on that before I wrap up this session? Yes, sir.
Yes, you mentioned that there is a relative GSR about application isolation, right?
Yes.
On the .NET platform, I think there is something like the regulatory process.
Yep.
So, on the other hand, the JDK8, not 8, but 9 maybe, we have the module.
Mm-hmm.
Maybe one day.
You say 9 or 19?
With the module, the help with the help in the same way as the application isolation, or not?
It could help. It probably won't help that much. One of the things that I want to look into, I just haven't got the time yet, is what they're doing in Java 8. I don't know if Antonio, you might know this. What they're doing in Java 8 about the permgen space, because I think they're getting rid of that in Java 8, aren't they? So that's going to be an interesting one as well. No, it's different to that, I believe. Yeah.
It's out. It's removed from Hotspot 8. Yeah.
Oh, yeah. Okay. So it's removed from Java 8 now.
Yeah, it's a WebLogic JRocket improvement.
Okay. Okay. So it's a JRocket improvement. Okay. But no, I don't see Jigsaw or... No, I don't think so. No.
Oh, but Jigsaw is dead. Well, I don't know if you have heard Mark Reynolds saying it's just, it won't happen the way we thought it would happen.
So Jigsaw is dead. So me saying Java 19 was actually being optimistic. Okay. Something which might be of use as well is I think there's a JVM thing you can do where you unload class. And I think what it does is it's unload classes on the class loader, where what you're effectively doing is you're just cutting off the class loader from all the classes, and as a result, all those classes can kind of maybe be, all the other classes can kind of be garbage collected as well, so you reduce the chances of getting this kind of exception earlier. But no, even if modularity was involved, I don't necessarily see it as being anything that could have helped. But that's good news at least. Any other questions?
Sorry, sir. I basically didn't understand why it leaks. Because as you earlier explained, that the class loader actually hands over everything to its parent, so basically there shouldn't be any problem. But why it creates the whole tree of objects?
So the question was why does a class loader leak? The question was you didn't understand why the class loader would leak because it always hands over to its parent. So in this case, what we want to do is we want to delete the class loader which loaded the class which we are upgrading. So as a result, we need to find the class loader, and if that's a shared class loader, we need to do a hell of a lot of reloading. But if it's a web class loader, it's easier. So we find all the classes that we need to reload. We need to find all the class loaders that's associated with. We destroy all of them, and we bring up the new class loaders as their replacements, and then we can create all the new objects and things like that. But it's not easy when you have that many objects and that much state that you need to pull across for there not to be links between them. And as a result, as soon as there are links between them, the old versions can't be garbage collected. So as a result, you have 2 hierarchies, and then when you do it again, you have 3 hierarchies, and you continue with that because they're all continuously linked. So that's the reason it happens. Does that make sense?
Yes, so basically it's automatically a question of garbage.
Yes. Yeah. Was there another question over here somewhere? Yeah.
Maybe to launch a new process to take account the new class, but Intervenant we can't communicate with the new process.
Processes are a potential answer because that's where you get your isolation from. There's 2 separate processes. The way that Java works with its threads, and it wanted to take on threading by itself when it was bored, it's a great thing and it's a horrible thing. Because the idea of having a thread which exists inside your JVM, and then another thread here and another thread here, you can very easily get entangled. If they were separate processes, if it left it to the operating system to have separate processes, you'd then effectively have communication between the processes rather than hard links. Processes is an option, but it's something again that we are unlikely to get. Any other questions? Yeah.
When gReveal reloads the classes, isn't there a way to see if there is a leak, to detect the leaks?
With JRebel?
Or something else, like, isn't it possible to keep a soft reference to the class loader and see, okay, was it removed or not? And if it's not, you throw an exception or you log an error, there is a leak.
So this gentleman here has just asked for a JRebel demo. So I'm going to show you a JRebel demo. What JRebel does differently to what we've discussed before is rather than create everything from scratch and throw away your old class loaders, what JRebel will do is it will sit in the old class loader and it'll intercept. It's a Java agent, so it intercepts when classes are loaded. And we add a whole bunch of bytecode in to say, you're not going to load this object directly, you're going to go through me. And as a result, I'm going to load my version of the class. And as and when you make changes to that class, I'm going to update my version and expose that to the runtime. So the class loader is effectively only loading once. And so you avoid the throwing away and the reconstruction. So the object, so the problem disappears. So let me show you an example. I'm going to only do this for a couple of minutes because I don't want to. I don't want Jerable to be front and foremost, but you should all go out and buy it. So I'm going to show you, this is the pet clinic. I'm sure everyone's seen the pet clinic. It's one of the most boring applications, but most used applications. Cyril, you use pet clinic as well for your demos, don't you? Yeah, pet clinic. Where is the pet clinic? Our friendly faces of that dog and cat, where are they? Here. There's the pet clinic. So what we're going to do is we're going to change some classes. We're going to change some Java resources. And Jerable's going to automatically change the class, but remain within the same class loader. We're not throwing any class loaders away. We're not loading the class again. First thing we're going to do is a Java resource. So this welcome message at the top here. I'm going to go into my messages.properties. I'm going to say, welcome to the Paris Jug Pet Clinic. It's a new side project for the Paris Jug. What we're going to do is we're going to go straight there. And although the clinic bit is cut out by this picture, you can see that we upload it straight away. So what we've effectively done is we've added this messages.properties file into the runtime. We've poked the runtime to say, hey, we've upgraded this. You need to reload it again. And this is just a kind of container thing to say, don't read it just once, but reload it every single time I ask you to. But we're more interested in we're more interested in a code change. So I'm going to show you a more functional code change. Here we have a whole bunch of validation on each of these text boxes. We have is required as our error message because they're blank. I'm going to go into the owner validator form, and I'm going to do some funky things. Let's remove this part here. Hit save. I'm going to remove the address and the city. Each one of these are validations for each of our input boxes. I'm going to extract that to a new method. Let's do some refactoring. I'm going to add a bogus key here. Bogus key. So this doesn't exist in our messages.properties file, but we're going to add a default message here. So just to show you that this has changed between our refactor. Let's add a new key here, the get city, and in our messages.properties file, we'll add ourselves a new key, which is city is required. Hit save. Come out of that, and all I need to do, hit add owner again. First name has disappeared. We get our new refactoring. We get a new lookup into our messages.properties, which has also changed. This is our default message, and if I look at our console, no, not that console. This console. If we look at this console, apart from the exceptions, that was the class loaders issues that we had before. Honest. We have some reloaded bundles. So we've reloaded our messages.properties for our welcome message, and we've reloaded both our owner validator and our messages.properties for our second change. No class loaders were hurt in the reloads of these classes. The entire structure has remained, and all we've done is change the objects from within. So there has been no reload. There has been, the class loader has still only loaded once. So I'm not going to talk about Jerable anymore, but it's awesome. You should look into it, so I can continue to travel with zero turnaround. If you wanted to know more about this, you go to jerable.com and you can see more information about that. There's also a whole report about class loaders which we have put together. That's on Rebel Labs. In fact, what I'll probably do during the second session, I'll send an iPad round, and there's a whole load of links that I've got to these slides, reports that back this entirely up, and stuff like that. Before we go to some dinner, the one last thing I wanted to talk about is something called the VJug. Is it okay to mention this? The VJug is a new jug that I founded. Jugs like this are absolutely awesome because local jugs are amazing. One of the biggest things about a jug that you can do is network with people, talk to people, go for a beer with people. I got my job at Zero Turnaround because I'm a member of the London Java community and talk to people like Martijn Verburg, right? These are the connections that are really, really important. But now I live about 40 minutes away from London, and my little boy and my wife, they quite like to recognise me. So I don't want to go into London every single night and miss an entire evening and not be at home. So I created this virtual jug. It's an online-only jug, so it's effectively awesome speakers who are presenting on the VJug, and there's a whole load of discussion in IRC while the session's happening. You can ask questions to the presenters, and it's nice and interactive. Examples of the sessions that are coming up in January: we have Aaron Gupta talking about an introduction to Java EE7. We have Simon Ritter from Oracle talking about Java 8. And we have Sven Peters, who has an awesome presentation about how to do Kick-Ass development. 3 really, really good presentations from 3 awesome speakers. It's entirely free to join, obviously. If you did want more content, feel free to join and come to whichever sessions you'd like. So with that, this is virtualjug.com, by the way. I'll send that as a link as well, and I'll send the iPad round as soon as we start the second session. So with that, thank you very, very much for your for listening to me and laughing at some of my jokes. And let's grab some